So today we're going to work on hypothesis testing. I've got a nice simple example here for you. Hypothesis testing is a way for us to test a hypothesis, as it should say. So to get started, H sub 0 is always denoted as our null hypothesis. So to get started, suppose we have an n sample size of 100. We're given a sigma, standard deviation, of 10, and a sample average of 80. What we're going to want to do is build a z-score for that, which for this is denoted as x bar minus mu on the numerator. As you'll notice, this is our deviation. Here in the denominator, we have sigma divided by the square root of n, which is our standard error. Now, usually when we're asked a question where we're going to use hypothesis testing, it's set up something similar like this. With an LOS, level of significance, of 0.01, is 82 the true mean? Now, when we say true mean, we're usually talking about the theoretical or hypothesized population mean, the mu. So for our hypothesis test, we're going to want to set up what is that null hypothesis. That can help us writing it down to make sure we visualize and keep it straight in our heads, what we're actually trying to deal with. So here, our mu equaled 82. That's our null hypothesis. So as we decide to go ahead and set this guy up, we have a nice formula here that we can plug in each of our values. So our x bar is 80. Our mu value is 82, which we're trying to test. Sigma was given here as 10, and n is given here as 100. So this is a nice, easy problem. Our numerator comes out to 2, and on the denominator, we have 10 divided by the square root of 100, which will also be 10, so it comes to 1. So now we've got this standardized z-score for our data from the sample. What we want to do now is find out how do we know whether or not it's equal to the true mean or not. What we'll do then, since we were asked about a level of significance, sometimes denoted, oftentimes actually, as 0.01. Now when we looked at 0.01 in the z-table for our critical value, we find that it's a plus or minus 2.58. So I've drawn our nice normal bell curve here with a negative 2.58 on the left side and a positive on the right side. Now what our z-score here that we calculated for our data is saying is that we've got a negative 2 here. That means it does not reach what we call the rejection region. Now, if our data that we've collected does not reach the rejection region, that means we cannot reject the null hypothesis. Therefore, since we have a 2, and the rejection region requirement is to be going past the negative 2.58, we cannot reject the null hypothesis.